Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of P1 variant 11 of November 2020. And for this, I am using the work of an outstanding and one of my best student, Miss Subika Heather, class 2022 of KGS. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to three significant figures or one decimal place for angles in degrees, unless a different level of accuracy is specified in the question. Must follow these instructions. An important advice for me and for everyone. We should be good to others. Few important tips to solve the paper in a good way. Number one, avoid careless mistakes. Number two, read the questions carefully. Question number one, find the set of values of m for which this line and this curve do not meet. Do not meet means no real roots, and for that we use this discriminant. B square minus 4ac less than 0. Number one, we need to equate these two y's to get the quadratic equation. Here is the quadratic equation. By comparing this equation with the standard quadratic equation, which is ax square plus bx plus c is equal to 0, we have the values of a, b and c. After getting the values of a, b and c, we have to substitute these values into this discriminant. So we have minus m square minus 4a is 2 and c is 8 less than 0. By simplifying and factorizing this inequality, we have this inequality. Since we have lesser sign, therefore the required region is below the origin. And make sure you label the horizontal axis by m. According to this shading, m lies between minus 8 and 8. This is the solution of this inequality. It's here. Question number 2. This is the gradient of the curve, gradient of the tangent to the curve. It is given that the curve passes through the point 2 and 7. Find the equation of the curve. Since we have gradient of tangent to the curve, so by integrating this gradient, we can get the equation of the curve. So the left side, when we will integrate this left side, this will become y. And here we have to use a square bracket because we have two terms. And this sign of integral is multiplying with these two terms and dx is also multiplying with these two terms. So a square bracket is compulsory. So when you will integrate this linear composite function, you will get this x minus 3 whole power minus 1 divided by minus 1, which is the resultant power. This x will become x square upon 2, and this is the constant of integration. This is the simplified form of this equation. Now by substituting this point into this equation, we can get the value of c, which is 4. After getting the value of c, we need to substitute this value back into this equation to get the required equation of the curve. Make sure you do the calculations carefully. Question number 3. Air is being pumped into a balloon in the shape of a sphere so that its volume is increasing at a constant rate of 50 cm3 per second. This 50 cm3 per second is the rate of change of volume. This unit will help you. Cube means volume. The rate of change of volume is 50. Find the rate at which the radius, that means dr upon dt, is increasing when the radius is 10. Number one, we need to understand that this situation is for chain rule because one rate is given and the other rate is required. So whenever one rate is given and the other rate is required, we always use chain rule. Here is the chain rule. V, and this is the formula of volume of a sphere. If you know the formula, you can easily form the chain rule. So dV upon dt, dV upon dr, dr upon dt. This is the required chain rule with respect to this given information and this formula. So if you observe this formula carefully, then you would see that we have dV upon dt. We are working for dr upon dt. So we just need dV upon dr. And we can easily get dV upon dr by differentiating this v with respect to r. So when you will differentiate this equation with respect to r, you will get this thing 4 pi r square. And by substituting the value of r here, we can easily get dV upon dr, which is 400 pi. Now we have dV upon dt, we have dV upon dr, and we need dr upon dt. So this is 50, this is 400 pi. So we can easily get dr upon dt, which is 1 upon 8 pi or 0.0398. This is the exact answer, and this is the answer up to 3 significant figures. Question number 4. In the diagram, the lower curve has equation y is equal to cos theta, this curve. The upper curve shows the result of applying a combination of transformations to y is equal to cos theta. Find in terms of cos theta function, cosine function, the equation of the upper curve. See, this is very simple. Whenever we have the equation of the resultant graph and the function is in trigonometric form, then you can easily get the equation of this resulting graph. You must know this equation for that. See, this is the mean line C, which is 3. This is the maximum value of function y, and this is the minimum value of this function y. So C is 3 and C plus A is 5. Therefore, A is 2. Now, we need to work for B, and for that we need to use the formula of period. This curve has period 4 pi. So by writing 4 pi here, we can get the value of B. So after getting the values of A, B and C, we can easily get the equation of the resultant graph. This is the standard equation. By substituting A here, B here and C here, we have the equation of the resultant graph. This is so simple. Question number 5. In the expansion of 2x square plus a upon x whole power 6, the coefficients of x cube and x power 6 and x cube are equal. So we first need to find the terms which contains these coefficients, and for that we need to use this formula, the general term formula. So by substituting the values of a, b, c, r into this formula, we have this thing. So this simplified form of x is x power 12 minus 3r. Therefore, by equating this x with x power 6 first and then x power 3 next, we have the values of r. We equated this x with x power 6 and got this value of r. And we equated this x with x cube and we got this value of r. So by substituting these values of r into this equation, we have the coefficients of x power 6 and x power 3. This is the coefficient of x cube and this is the coefficient of x6. And both are equal. So by equating these coefficients, we have a 1.5. Part B. Find the coefficient of x6 in this expansion. We already have coefficient of x6 and x cube in of this expansion. We just need to multiply this expansion with these two coefficients. This is the coefficient of x power 6 and this is the coefficient of x power cube into this expansion of this expansion. So by multiplying 1 with this term, we have this term, 540 x power 6. And by multiplying x cube, negative x cube with this, we have this term, minus 540 x cube, x power 6. So by simplifying this, we have 0x6. Since we have to mention, we have to give the coefficient, so just write 0. Don't write, don't leave your answer here, because this is the term and this is the coefficient. Question number 6. The equation of a curve is this. Find the coordinates of the point on the curve at which the gradient is 4 upon 3. Number 1, you need to differentiate this. When you will differentiate this equation, you will get this thing. This 2 will become 0, and this 25 minus x square under root will become this 1 upon 2 under root, and the differential of this root is minus 2x. Now you just need to equate dy upon dx to 4 upon 3 to get the coefficient of x. So by equating this with 4 upon 3, by 4 upon 3 we have this thing. By solving this equation, we have two values of x, plus 4 and minus 4. We have to ignore plus 4. Why? Because when we will substitute plus 4 here, we won't get gradient 4 upon 3. We are getting gradient negative 4 upon 3. Since gradient is positive 4 upon 3, and we are not getting positive 4 upon 3 with this value of x, therefore we have to ignore plus 4. So the required value of x is minus 4. Now by substituting this minus 4 into this equation, we can get the value of y, which is 5. So these are the required coordinates of the point. This is important. You need to ignore positive value, because with this value of x, you are not getting positive 4 upon 3. You are getting minus 4 upon 3, and the gradient is positive 4 upon 3. So this is the required value of x, and this is the required value of y. Question number 7. We have to show this identity. This is so simple, you just need to take LCM of these two fractions. When you will take the LCM, in denominator you will get a minus b, a plus b, which will become a square minus b square. In numerator you have sine theta and 1 plus sine theta in bracket minus sine theta bracket 1 minus sine theta. By simplifying this numerator, you have this sine theta negative, sine square, sine square. You need to cancel these two sine thetas, and by simplifying these two, you have 2 sine square theta upon cos square theta. Sine square upon cos square is tan square, shown. Next part. Hence solve the equation. You just need to replace this thing by 2 tan square theta, because we just have proved this, that is, this entire thing is 2 tan square theta. So by substituting this entire thing by 2 tan square theta, we have 2 tan square theta equals to 8. Finally, we have tan theta plus minus 2. This means tan is in first and in second quadrant. For this domain, you need to work only in first and second quadrant. So this is the value of alpha, 63.4. So when tan theta is in first quadrant, the answer will be 63.4. When tan theta is in second quadrant, the answer will be 116.6, because this is 63.4. So these are the required answers. Next question, number 8. A geometric progression has first term A, common ratio R. and sum to infinity is s. This is the first GP and the data is here. The first term is a, common ratio is r, and sum to infinity is s. This is the second GP. The first term is a, common ratio is capital R, and sum to infinity is 2s. So we just need to form two equations with this data and this data. With this data, we have this equation. And with this information, we have this equation. By solving these two equations simultaneously, or by equating these two equations, we have the value of small r. We have shown this. This is what we had to show. Next part. It is now given that the third term of the first progression, that means T3, which is AR square, is equal to the second term of the second progression, which means AR, which is here. So T3 is equal to T2. By solving this equation, we have this. R is 1, R is 1 upon 4. We substituted R, small r by 2r minus 1 here. Since sum to infinite only exists when r lies between minus 1 and 1, therefore we need to reject this value. So this is the required value of r. Now by substituting this value of r over here, we can get the relation of s in terms of a. This is the relation of s in terms of a, and this is what we had to find. Next question. The diagram shows a circle with center A passing through the point B. This is circle 1 and this is circle 2. This circle has center A and this circle has center B. A second circle has center B and passes through A. So this is the radius. This is also the radius and this one is also the radius. The tangent at B, this tangent, to the first circle intersects the second circle at C and D. Number 1, find the equation of this tangent. We have the coordinates of the centers of both the circles, A and B. So, number 1, we need to find radius of this circle, second circle. The radius will be BA, distance BA. Since we are working for the equation of the tangent, therefore we first need to get the gradient of this line BA. The gradient of this line BA is negative half. Therefore, gradient of this tangent would be 2, because tangent is perpendicular to radius. So the gradient of the tangent is positive 2. We have the point on the tangent, which is 3, 2. Therefore, this is the required equation of this tangent. So number 1, you need to work for the gradient of this tangent. First find gradient of AB and then take the inverse reciprocal of this gradient to get the gradient of this tangent. We have the point, we have the gradient, we can easily get the equation. This is the required equation of this tangent. Number 2, we need equation of circle. For that, we need to work for radius. This is the radius. Distance AB is the radius. So this distance is under root 20. So the equation of the circle will be x minus 3 whole square, y minus 2 whole square equals to 20, because this is the standard equation of the circle. X minus a whole square, y minus b whole square is equal to r square. And center is AB. And circle 2 has center 3, 2. So this is the required equation of circle 2. Number last part, the next part, find the coordinates of C and D. This is so simple. We just need to solve this equation of line. I mean, we need to solve equation of this tangent with the equation of this circle, because this line intersects the circle at 2 points. So by solving the equation of this line with the equation of this circle, we can easily get the coordinates of x coordinates of C and D. Here is the equation of tangent and this is the equation of the circle. By substituting y here, we have this equation. By simplifying and factorizing this equation, we have the coordinates of C and D. This is the x coordinate of D and this is the x coordinate of C, because C is above the D, or C, the x coordinate of C is greater than the x coordinate of D according to the diagram. Question number 10. The diagram shows the sector CAB. This is the sector CAB with center at C. A circle with center O and radius R lies within the sector. Here is the circle and touches it at D, E and F, where COD is a straight line and angle ACD is theta. This angle is theta, so this must be theta. Well, this is the radius of the circle and this is the radius of the sector. CD, this length, is the radius of the sector CAB. The first part of this question is find CD, this distance, this length. And for that we need to use sine theta into this triangle, because this is the opposite and this is the hypotenuse. CD is the CO is the hypotenuse, because CD is CO plus R. This is CO and this is R. When you will add these two, you'll get CD. So first work for CO. And for CO you need to consider this triangle. Let me draw this triangle here. This is theta, this is C, F and O, R, we need CO. CO is hypotenuse, this is opposite. So by using sine theta into this triangle, we have OC or CO, R upon sine theta. So we have got this distance or this length. This is R upon sine theta. Therefore, this total distance will be R upon sine theta plus this R. This is what we had to find, CD. And this is the radius of the sector CAB. The next part. It is now given that R is 4 and theta is pi by 6. Find the perimeter of sector CAB. This is so simple. This is the sector CAB. This is theta, which is pi by 6. This is also theta, so the total angle will be pi by 3. And small r is 4. So by substituting the value of R4 into this equation, we can easily get the radius of this sector. This is the radius of the sector, 12. So perimeter is simple, sum of the boundaries of this sector, 12 plus arc length. Arc length is 4 pi. This is the perimeter of this sector. In the next part, find the area of the shaded region. We need this area. This is so simple. By subtracting the area of this sector from the areas of these two triangles, we can get this area. Number one, we need to work for the area of this triangle. So number one, get this length CF, and for that you need to use tan theta into this triangle, because this is adjacent and this is opposite. So by using tan theta into this triangle, we have CF, which is 4 under root 3. Now find the area of this triangle. Since both the triangles are congruent, therefore just find area of this triangle and multiply this area by 2 to get the area of these two triangles. So area of this triangle is 8 root 3 and the total area will be 16 root 3. Area of this sector is 16 pi by 3. Because this angle is pi by 3, this angle is pi by 3, so this angle will be 2 pi by 3 because the sum of these two angles is always pi. This is 60, so this must be 120 and 120 means 2 pi by 3. It's here. So area of this sector is 16 pi by 3. Now by subtracting this area from 16 root 3 from the areas of these two triangles, we can get the area of required region or shaded region. This is the answer in exact form. Question number 11. F is defined for this domain and G is defined for this domain. We need the expression for Fg, and for that we need to substitute the x of f by g. We just need to replace this x by g. So the answer will be 2x plus 1 whole square plus 3. Part B. Find an expression for Fg inverse. This is so simple. You just need to replace this by y first, and then you need to separate this bracket, and then you have to take a square root on both sides. When you will take the square root, you will get two answers, plus minus. But this is very important. The domain of Fg is the domain of G, and the domain of G is here. And since x is increasing according to this domain, see, we have greater sign, therefore x is increasing. So we have to just take plus sign from these two. It's here. We decide plus or minus according to the domain. When domain has greater sign, then we choose plus sign, or vice versa. So this is very important, positive sign because of this domain. Now replace x by Fg inverse and y by x. So this is the domain of Fg and this is the function Fg. So if you make a rough sketch of this function, you will get this thing. This is the rough sketch of this function, and this is the domain. According to this domain, you need to remove this part. You just need to sketch from here. This is the required sketch. This is the function Fg, and it is true for this domain. So if I ask you write down the range of this function, then you can easily write the range. See, y is increasing from 3. This is the y coordinate of turning point, and this circle is unshaded because x, the domain is exclusive. So this is the range Fg greater than 3. This is the range of this function. Now this will help you to write the domain of this inverse function. So whenever they ask write the domain of Fg inverse, you need to work for the range of Fg. This is the range of Fg, and this will become the domain of Fg inverse. Here is the domain. Let me repeat this. This function has domain x greater than minus half. This is the domain of function g, because in Fg, f depends on g. After writing the domain, make the rough sketch of this function with respect to this domain. This is the rough sketch. Now write down the range of this function. Since y is increasing from 3, so this is the range of this function. And this must be exclusive because the domain is also exclusive. Now this range will become the domain of this function. This is the rule of the range and domain of inverse functions, because inverse is the reflection of y is equal to x, about y is equal to x. This is the next part. Solve these two equations. This equation fg and gf minus 3. See, the domain of f is this and the domain of g is this. So when you will solve this equation, you will get two values. Make sure you will check your answers with these domains. So this answer will be rejected because according to these two domains, this number is not correct or right, because x is greater than 0, x is minus half. This number does not lie in these two domains. Therefore, you have to reject this answer. So the only answer is 1. Always check your answer with the given domains while solving the questions of composite functions. I think this is the last question of this paper. The diagram shows the curve with equation this, and this is true for x greater or equal to 0, or valid for these values of x. And this is the equation of this straight line. This straight line has equation this. The curve crosses the x-axis at A and crosses the straight line at B and C. Find by calculation the x coordinates of B and C. This is so simple, you just need to solve these two equations simultaneously. So when you will solve these two equations simultaneously, you will get these values of x, 1 and 9. So the x coordinate of B is 1 and the x coordinate of C is 9. You need to use substitution. You need to suppose under root x as y. So this is y and this will become y square and this will become y square. These are the values of y. By substituting these values of y one by one into this equation, we have these two values of x. Show that B is a stationary point. If point is stationary, then the gradient of the tangent at that point will be 0. So you need to differentiate this equation. This is the gradient of the tangent. You all know how to differentiate this equation. Under root x will become 1 upon 2 root x and minus 2x will become minus 2. So this is the gradient. By substituting 1 into this equation, we have 0 shown. When gradient is 0, that means the point is stationary. The last part of this question, find the area of the shaded region. This is so simple. This area is required. And this area is occupied between the line and the curve. Number 1, you need to find area of the triangle. This is the total area. So first work for the area of triangle, this triangle, and then find area above this curve. And then subtract area above the curve from area of triangle. So number 1, work for area of triangle. This number is 3 and this intercept is 9. So the base of this triangle is 6. C has these coordinates 9 minus 6. So the height of this triangle is 6 because distance is always positive. So the area of this triangle will be 18 because height is 6 and base is also 6. So we have found the area of triangle, which is 18. Now we need to work area above this curve. For that we need to use these two values of limits, values of x as lower and upper limits, 4 and 9. Since this curve is below the x-axis, so you need to write negative sign before the sign of integral. So when you will integrate this equation with these two limits, you will get this thing, 14 whole 1 upon 3. This is the area above the curve. So when you will subtract this area from area of triangle, you will get the required answer, area of shaded region. Well, this is all from this lecture. An important advice for me and for everyone, we should be generous to others. Good luck. And I am extremely thankful to Miss Subika Heather to help me to make this lecture. Indeed, she is an outstanding student. May Allah Pak bless her always. May Allah Pak give her the best grades. Ameen. Allah Hafiz.